All right, let's take a look at question 1, problem A. We're supposed to sketch a graph of the following. We're supposed to determine all x and y intercepts. And remember that on this review and on your exam, we're not allowed to use a calculator to produce a graph or a table of values. So we start off with the curve y equals x to the fourth. Let's put in our x and y axes here. Y equals x to the fourth. We've already taken a look at this curve. We know that y equals x to the fourth, y equals x to the sixth, all look very much like y equals x squared. They all look very parabola-like. If we wanted to find a few values on the curve just to see exactly what this looks like, we could make a little table of values, y, x, and y. So y equals x to the fourth. So if we put in x equals 0, 0 to the fourth power is 0. If we put x equals 1, 1 to the fourth power is 1. If we put x equals minus 1, minus 1 to the fourth power is 4 minus 1's all multiplied together, and that gives us positive 1. So we know that this thing goes through the curve, it goes through the point 0, 0. It goes through the point 1, 1. It goes through the point minus 1, 1. And again, it looks very parabola-like. It's just steeper over here and a little squarer over here than the parabola is. So it's not a parabola, but it has a similar shape to the parabola. So it looks something like that. Sorry, my picture isn't better, but I think that will be good enough for our purposes. Let's move on to part B. So in part B, again, we're building this thing off of the x to the fourth curve, the same curve we had up here, but we have x minus 1 to the fourth plus 2. So we've taken the x to the fourth curve, and we've done two transformations to it. So we already have the y equals x to the fourth curve. Let's graph y equals x minus 1 to the fourth power. So looking at this, we see we've taken the curve y equals x to the fourth, and we've subtracted 1 directly from the x. We know this is a horizontal change. Horizontal changes are in the changes to the x, or horizontal changes are in opposite to the direction you'd think. So you'd think minus 1 would be to the left, but it's actually a shift 1 unit to the right. So we've taken this curve and we've shifted it over 1 unit to the right. So we can see where this thing crosses, or touches the x-axis. Here we have, so back up in A, we had an x-intercept at x equals 0, and a y-intercept at y equals 0. That's the only place where the axes are touched. But down here, we've shifted everything over 1 unit to the right. We can see that we have our x-intercept. Well, actually, we're not quite done yet. We have to take a look at x minus 1 to the fourth, and then we have to do the plus 2. So let's do the plus 2 now. So y equals x minus 1 to the fourth power plus 2. We know the plus 2 does a vertical change. It just shifts everything up 2 units. So this point right here goes up 2 units. So there's 1, here's 1, 2. We shift everything up 2 units. We can see from the shape of this picture that this isn't going to cross the x-axis at all, so there is no x-intercept. Can you see that? No x-intercept. As for the y-intercept, we always find the y-intercept the same way, and that's by plugging in x equals 0. So let's plug in x equals 0. So we'll set x equal to 0, and we end up with y is equal to 0 minus 1 to the fourth power plus 2. all I did is put a 0 in for x. And when we do that computation, we end up with minus 1 to the 4th power. That's 1 plus 2, or 3. So this thing crosses the y-axis at 3. So let's see, I think we've done everything we need to do in part A and part B. Let's take a look at part C. So in part C, we're looking at x cubed minus x. And let's figure out where this thing crosses the x and the y axes. So for our x-intercept, sorry, let's start with our y-intercept, that's easier. For our y-intercepts, we again set x equal to 0. And we end up with y is equal to 0 cubed minus 0, which equals 0. So we have a y-intercept at 0. Now let's do our x-intercepts. We'll set the whole thing equal to 0, so y is equal to h of x. So we'll set x cubed minus x all equal to 0. Now we have some factoring to do, so we can go ahead and do that. Is it clear? Let's see. So we have some factoring to do. So we can factor out an x, that leaves us with an x squared minus 1. And so we have x times x minus 1 times x plus 1 equals 0. X is 0 at 0, 1, and negative 1. And so we can see that this thing crosses the x-axis 3 times. So let's draw some x and y axes here. So we know it crosses the x-axis 3 times. 1, 2, 3. Now let's figure out where it's above and below the x-axis. Let's do a sign chart for x cubed minus x. I'll put my sign chart directly below my curve. So 1, 2, minus 2. So 0, 1, 2, minus 1, minus 2. And I can see that the height is 0 there, there, and there at minus 1, at 0, and 1. We worked that out already. We've broken the real line down into 3 parts, or 4 parts rather. The part to the left of minus 1, the part between minus 1 and 0, the part between 0 and 1, and the part to the right of 1. All we have to do is plug in a value in each part to see whether it's positive or negative there. So let me plug in a value to the left of minus 1. So h of minus 2 is equal to minus 2 cubed minus minus 2. And this works out to minus 8 plus 2, which is equal to negative 6. So it's negative over here. And to tell you the truth, I'm just going to speed things up a little bit. If you plug in a value between minus 1 and 0, it works out to be positive. If you plug in a point between 0 and 1, it works out to be negative. And if you plug in a point to the right of 1, say 2, it works out to be positive again. So it's below the x-axis over here, above the x-axis, below the x-axis, above the x-axis. We know this is a third-degree polynomial, so its endpoint behavior is it goes up to infinity in one direction and down to minus infinity in the other direction. The coefficient in front of the x cubed is a 1, so we know it goes up to infinity to the right. So it's up here, it's down here, it's up here, it's down here, and we have a pretty good idea what this thing looks like now. So it's negative, and then we can see it's negative over here, and then it's positive for a while. You can see it's positive between negative 1 and 0, then it hits 0 again. Now it's negative for a while between 0 and 1, and now it's positive after 1. So where the plus signs are here, we're above the x-axis. Where the minus signs are, we're below the x-axis. We know it goes up to infinity on the right and down to minus infinity on the left. And I think that's probably as good a graph as we could possibly hope for. Let's look back at B again. So we've taken the curve y equals x to the fourth, we've shifted it over 1 unit to the right, and then shifted it 2 units up. We have our x and our y intercepts. Oh, did we write down our, yeah, I guess we wrote down our x and y intercepts down here too. And looking back in part A, we have the curve y equals x to the fourth, which looks very parabola-like, only crosses the axis at x equals 0 and y equals 0. Okay, let's move on to the second page. Find all zeros of the polynomial p of x equals 3x to the fourth minus 2x cubed. Hopefully that's visible. 3x to the fourth minus 2x cubed minus 12x squared minus 6x plus 6. We know that if p over q is a root, is a rational root, then p divides 6 and q divides 3. So if p divides 6, p is equal to either plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 3, or plus or minus 6. And if q divides 3, q is equal to plus or minus 1 or plus or minus 3. So we can try a few values. If we try p equals 1, we see that 3 minus 2 is negative 1 minus 12, is 1 minus 12 is negative 11 minus 12 plus 6. That gives us minus 6. That doesn't work. But we can try p equals minus 1. So let's try p equals minus 1. Let's try p over q equals minus 1. So we'll plug in p of minus 1. That equals 3 times minus 1 to the fourth power minus 2 times minus 1 cubed minus 12 times minus 1 squared minus 6 times minus 1 plus 6. And with any luck, this gives us 3 plus 2 minus 12 plus 6 plus 6. Oh, sorry, that shouldn't be a plus 6. There's no 6 there. There's just a 1. So this should be plus 1 plus 6, so that's 5. Minus 12 is negative 7. Minus 6 plus 6 is 0. So this is equal to 0. So right away that tells us that one of the zeros of the polynomial is negative 1. And it tells us that x plus 1 is a factor. So x equals minus 1 is a 0. X minus negative 1, which is the same as x plus 1, is a factor. Now we have to go through and divide by it. So let's move over here. So x plus 1 goes into 3x to the fourth minus 2x cubed minus 12x squared minus x plus 6. X goes into 3x to the fourth. That means what do I multiply x by to give me 3x to the fourth? Well, I multiply it by 3x cubed. Now I'm going to multiply 3x cubed by x plus 1. So that gives me 3x to the fourth plus 3x cubed. I'm going to subtract. The 3x to the fourth cancel out. Minus 2x cubed minus 3x cubed is minus 5x cubed minus 12x squared. I multiply x by minus 5x squared to get minus 5x cubed. Minus 5x squared times x is minus 5x cubed. Minus 5x squared times 1 is minus 5x squared. I'm going to subtract. So minus 12x, well, the 5x cubes cancel out. Minus 12x squared plus 5x squared is minus 7x squared. I'm going to bring down the minus x. What do I multiply x by to get minus 7x squared? Well, I multiply it by minus 7x. So minus 7x times x is minus 7x squared. Minus 7x times 1 is equal to minus 7x, but I'm going to subtract. The minus 7x squareds cancel out, and I'm left with minus x minus 7x, which is plus 6x. Bring down the plus 6. X times 6 equals 6x. So 6 times x plus 1 is 6x plus 6. The remainder is equal to 0. So that tells me that this is my other factor. So that tells me that p of x, which was that original polynomial, 3x to the fourth minus 2x cubed minus 12x squared minus x plus 6 is equal to x plus 1 times all this. 3x cubed minus 5x squared minus 7x plus 6. Now again, if p over q is a rational 0 of all this, let's call the whole thing q of x. So if p over q is a rational 0 of q of x, it's a little bit bigger here. Then p divides 6 and q divides 3. Basically, we have exactly the same choices we had up here. So we can start trying values. 1 doesn't work. Minus 1 doesn't work this time. We can go through a variety of values, but we'll eventually hit on p over q equals 2/3. So let's try 2/3. So q of 2/3 equals 3 times 2/3 cubed minus 5 times 2/3 squared minus 7 times 2/3 plus 6. And so this is equal to, let's see, 8/9. And what we have here is minus 20/9. So 7 times 2/3 is minus 14/3 plus 6. And let's just keep working on that. This is equal to, so 8/9 minus 20/9 is minus 12/9, which is the same thing as minus 4/3 minus 14/3, 14/3 plus 6. Minus 4/3 minus 14/3 is minus 18/3. That's minus 6 plus 6, which equals 0. So that tells us that x minus 2/3 is a factor. Now I'm not going to leave it as x minus 2/3 because that would make the division quite difficult. I'm going to multiply this whole thing by a factor of 3, so I end up with, so 3 times x is 3x, 3 times minus 2/3 is minus 1, is minus 2 rather. So 3 times minus 2/3 is minus 2. So I'm going to divide by 3x minus 2. So let's put that in. Let's move over here. So we'll put in 3x minus 2, and we'll divide that into our q of x. So our q of x was equal to 3x cubed minus 5x squared minus 7x plus 6. So we'll put that in over here. 3x cubed minus 5x squared minus 7x plus 6. Now we'll do our division again. 3x goes into 3x cubed. It goes in x squared times 3x is 3x cubed. X squared times minus 2 is minus 2x squared. We will subtract. The 3x cubes cancel out. Minus 5x minus negative 2x is minus 5x plus 2x squared. So that gives us minus 3x squared. I'll bring down my minus 7, minus 7x. So 3x goes into minus 3x squared minus x times 3x. Minus x times 3x is minus 3x squared. Minus x times minus 2 is plus 2x. We're going to subtract. The minus 3x squareds cancel out. 7x minus 2x. So minus 7x minus 2x is minus 9x. We'll bring down our plus 6. 3x goes into minus 9x, exactly equal to minus 3 times. So minus 3 times 3x is minus 9x. Minus 3 times minus 2 is plus 6. The remainder is 0, as we knew it was going to be. The remainder had to be 0. So that tells us that we can factor q of x as the product of that and this. So we said that p of x was equal to x plus 1 times what we called q of x, which was 3x cubed minus 5x squared minus 7x plus 6. And we just factored this as 3x minus 2 times x squared minus x plus minus 3. X squared minus x minus 3. We already have two zeros. We already have negative 1 as a 0. And we already have 2/3 as a 0. Now we just have to find the zeros of this thing. Now, this doesn't have any rational zeros, but it's okay because we can use the quadratic formula. So let's go ahead and do that. So if we set x squared minus x minus 3 equal to 0, that tells us that x is equal to, make a big fraction, minus b. B is minus 1, so minus b is going to be minus negative 1 or plus 1, plus or minus the square root of b squared. So b squared is minus 1 all squared minus 4 times 1 times minus 3 all over 2 times 1. And that equals 1 plus or minus, let's see what's under the square root sign. So that's 1 plus 12. That's 1 plus, so that's 13 all over 2. So we have two more zeros, which are 1 plus root 13 over 2 and 1 minus root 13 over 2. These are the four zeros. And I think that's what we were asked for in the problem. Find all the zeros of the polynomial, and we seem to have them on the page now. So again, this one gives us the minus 1. This one gives us 2/3. This one gives us 1 plus root 13 over 2, 1 minus root 13 over 2, and we're done. Let's move on to question 3. For each of the following, determine all x and y intercepts and all horizontal, vertical, and oblique asymptotes. Okay, so let's go ahead and take a look at this first one. So we're not going to do oblique asymptotes. We said we weren't going to do that, so we're not going to worry about that. So I guess that means that we're not going to worry about part C, but we'll get to there in a second. But let's worry about parts A and B first. So f of x equals x over x squared minus 1. So let's factor the denominator, x over x minus 1, x plus 1. And let's see, x and y intercepts. So for x intercepts, we set y equals 0. So y, of course, is just equal to the whole function. And so we have x over x minus 1, x plus 1 equals 0. If a fraction equals 0, it means the top equals 0, so x equals 0. So this just intersects the x-axis at 0. For the y-intercept, that's even easier. We'll set x equal to 0, if I set x equal to 0 in this whole thing, I have 0 over negative 1. I end up with y equals 0. So this thing crosses the x-axis at x equals 0, and it crosses the y-axis at y equals 0. Okay, let's see. Now we need to worry about horizontal and vertical asymptotes. Well, we can see that the numerator has degree 1. The largest power of x in the top is 1. The largest power of x in the bottom is 2. When the degree of the top is smaller than the degree of the bottom, we know we have a horizontal asymptote at height y equals 0. For our vertical asymptotes, we'll take a look at the factored form. And we see that we can't cancel. This thing has two places where it's not continuous at x equals 1 and x equals minus 1. We can't cancel either one with the numerator, so this thing has two vertical asymptotes. It has a vertical asymptote at x equals 1 and a vertical asymptote at x equals minus 1. So x equals 1, x equals minus 1 for the vertical asymptotes. Okay, let's go ahead and see if we can graph this thing. So put x equals 1 here, x equals minus 1 here. I will dot in my vertical asymptotes. Those are supposed to be vertical lines at 1 and minus 1. So here we are on the x-axis, here we are on the y-axis. We know it only crosses the axis right here. It only crosses the x and the y-axis right at x equals 0. We worked out that that was the only x-intercept and the only y-intercept. And so now let's go ahead and do a sign chart for this thing. And we know it's 0 at x equals 0. We worked out the y-intercept was the x-intercept was at x equals 0. It's the only place where it's 0. We know it's undefined at minus 1 and 1. You can use a little infinity symbol there or something else. I'm going to use a little u. And we've again chopped the real line up into 4 parts. We can plug a value into our original function. So the original function in each of these 4 parts down here. So to the left of minus 1, between minus 1 and 0, between 0 and 1, and to the right of 1. If we do that, we will see that the curve comes out positive over here. It comes out negative over here. Then it comes out positive, then it comes out negative, and then it comes out positive again. So we can see it's below the x-axis over here, it's above the x-axis over here, it's below the x-axis over here, and it's above the x-axis over here. So I think we should have enough information to be able to graph this thing now. To the left of negative 1, we can see that it approaches this line asymptotically, it approaches this line asymptotically, and it's negative the whole time. So it's pretty much got to look like this, getting closer and closer to those two lines. Then between negative 1 and 0, it's above the x-axis, it approaches this line asymptotically. So it gets closer and closer to that line. It goes through that point. So it's got to look something like this. Between 0 and 1, it's below the x-axis. It approaches this line asymptotically, goes through that point again. And to the right of 1, we know it's entirely above the x-axis. It approaches that line asymptotically, it approaches this line asymptotically, and it looks a lot like this. Now let's take a look at part B. So again, let's do our x-intercepts and our y-intercepts. Uh-oh.